Hello guys, trust you're doing fantastic. In today's video, we're going to be converting other number system to decimal number system. So the thing we need to understand is what is going to be the place value. Now we have the formula to convert other number system to decimal number system using the formula summation of the digits multiplied by the radix raised to the power of the place value. Now we're going to consider different scenario where we have decimal points and where we have a whole number. We're going to determine what will be the place value before the decimal point and after the decimal point. So let's take for an example. So we have 1100 base 2 equal to x base 10. The question says find x. So in this case, we're actually converting base 2 to base 10. So in this case, all we need to do is to assign the place value to each of those digits. So we'll begin from the left to the right. So we're going to assign 0, 1, 2, 3. All right, so that is going to be the place value. So once we have assigned that, the next thing we need to do is to multiply the digits by the radix raised to the power of the place value. So the first thing we need to do, so this is 1, so we say 1, which is this one, multiply by the radix. The radix is nothing but the base. The base value is 2, which is same thing as the radix, multiply by 2. Now raised to the power of the place value. So what is the place value for this first digit? It's 3 raised to power 3 plus. We take the other value, which is 1, say 1 multiply by the base. The base is 2. Now raised to the power of the place value. The place value for this is 2 raised to power 2 plus the other value is 0. So we're going to have 0 multiplied by the base. Now raised to the power of the place value, which is 1 plus the other value is 0. 0 multiplied by the base number. The base number is 2. Now raised to the power of the place value. The place value for this digit is 0. So 0. Anything multiplied by 0 is going to give us 0. So it means all of this is going to be eliminated. So we're going to be left with 1 times. Now 2 raised to power 3 will give us 8. We have 8 plus 1 times 2 raised to power 2 is going to give us 4. So plus 0 plus 0. So this will amount to 1 times 8 will definitely give us 8 plus 1 times 4 will give us 4. Right, so plus 0, so that will give us 12. So this is very easy, very easy. Now let's consider an example where we have a decimal point. So we have 1100.01. Okay, so base 2 says convert to base 10. Right, so it says find x. So in this case, we need to also know how to determine the place value when we have a decimal point in the digit. So in this case, remember, we're going to take the place value for the digit before the decimal point, and then we're also going to take the place value for the digit after the decimal point. Now the place value before the decimal point, we're going to begin from right to left. This is going to be 0. This is going to be 1. This is going to be 2. This is going to be 3. And then for the part after the decimal point, we're going to begin with minus. So we start from -1. So just the digit after the point will begin. So at this point, we're going to be moving from left to right after the decimal point. So we're going to begin with -1. So we're going to have the first one is going to be -1. Then the other digit follows going to be -2, right? So the next stage is for we to carry out the summation of so we're going to carry out the sum of the product of all the digits. So we're going to say 1 multiplied by the base, which is base 2, raised to the power of 3, which is the place value for this first value 1. And we'll say plus 1 multiplied by 2 raised to the power of the place value, which is 2 plus 0. Everything is going to give us 0 at this point. plus. So we're going to have 0 times 2 raised to the power of minus 1. So this is also going to give us 0 plus. We have 1 multiplied by 2 raised to the power minus 2. All right, so all of this is going to give us 0, 0, 0. So we're left with 1 multiplied by 2 raised to the power 3 plus 1 multiplied by 2 raised to the power 2 plus 1 times 2 raised to the power minus 2. If we have to simplify this, we're going to get 2 raised to the power 3 multiplied by 1, so that will give us 8, plus 2 raised to the power 2 multiplied by 1, that will give us 4, plus, then 2 raised to the power minus 2 is the same thing as 1 divided by 2 raised to the power 2, and that will give us 1 divided by 4. So multiply by 1 is going to be 1 divided by 4. So we're going to have 1 divided by 4. All right, so that gives us 12 plus 1 divided by 4. So at this point, what we need to do is that we need to get the value for this fraction. So we say 1 divided by 4. What is the value for this fraction? So it's going to be 12 plus 0.25. Right, so that will give us final result of 12.25 base 10. So this is how simple it is for you to convert base 2 to base 10, considering two types of conditions where you have decimal point and when you do not have decimal points. So this is straightforward, very easy. So let's take another example where we have to convert octal to decimal number system. All right, so this is an example of octal to decimal number conversion. We have an example. At first, we need to determine the place value. Now, this is a decimal value without a decimal point. So this is a whole number without a decimal point. So in this case, we are going to consider only positive place value because there is no decimal point. Right? So this is a whole number without a decimal point. So the place value is going to be 0, 1. So we're going to say 1 multiplied by 8 raised to the power 1 plus 2 multiplied by 8 raised to the power 0. So in this case, we're going to have 1 times 1 times 8 is going to be 8 plus 8 raised to the power 0 is 1. 1 times 2 is 2. So the answer is going to be 10. Hence, 1, 2 base 8 is equal to 10 base 10. Now let's consider another example where you have a decimal point. So in this case, all we just need to do is to determine the value, the place value. So this is going to be 0, 1. And then for the digit after the decimal point, it's going to be minus 1, minus 2. So we're going to say 1 times 8 raised to the power 1 plus 2 times 8 raised to the power 0 plus 1 times 8 raised to the power minus 1 plus 0 times 8 raised to the power minus 2. So in this case, anything multiplied by 0 is going to give us 0. So we're going to have 8 raised to the power 1 is 8 times 1 is 8 plus 8 raised to the power 0 is 1. 1 times 2 is 2. Okay, plus we're going to have 1 divided by 8. So 8 raised to the power minus 1 is same thing as 1 divided by 8. So we're going to have plus 1 divided by 8. Now, all we need to do at this point, we need to get the value. We need to simplify this fraction, okay? So we're going to have 8 plus 2 plus 0.125. So that will give us 10 plus 0.125. So that will give us 10.125 base 10. So this is the answer for it. So we have considered two scenarios where we have a decimal point and where we do not have a decimal point. So the next exercise we're going to talk about is the hexadecimal to decimal number conversion. All right, so let's go to the next example. All right, so let's take this example. The first example says, like I said, we're going to use the same method where we're going to find the place value. Now, this is a whole digit without a decimal point. So it means that the place value is going to be positive. So this is going to be 0 and 1, 0 and 1. So this will be 1 multiplied by the radix, the base value, which is 16, raised to power of the place value, which is 1, plus All right, so the next value we're going to have f multiplied by the base value, which is 16, raised to the power of 0. So this will give us 1 times 16 raised to power 1. It's going to be 16 plus 16 raised to power 0 is 6 is 1. 1 times f is going to give us f. Now, since we know from the hexadecimal table, f is 15, and since f is equals to 15. And so we have 16 plus 15, now which will give 31. So we can say that 1f base 16 is equal to 31 base 10. So this is how simple it is. Very simple. In hexadecimal number system, the number ranges from 0 to 15, which means that the minimum value in hexadecimal number system is 0 and the maximum number is 15. Now, you need to realize that hexadecimal number system has both alphabets and numerical values. So it runs from 0 to 9 and from A to F. So A equals to 10, 11, 12, 13, 14, and 15. Now, A stands for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, and finally F stands for 15. So this is how we got the answer. So understanding this hexadecimal table makes your work very easy. Please pay attention to the subsequent videos in this channel. All right then, enjoy the video. Bye.